Alright, so example 2 is basically the same thing, it gets a little more complicated from here. So what we're going to do is we're going to set this up and show you kind of the steps of how to isolate this absolute value. So again, we have to get this part, what I have in blue, all by itself. That means this 2 and this -5 has to move. So the easiest way to kind of set that up is, because this 2 is so close to it, I'm going to leave that for my last step. The first thing I want to do is, again, isolate this 5 and move it across this equal sign to this opposite side. Now, what's going to happen is I have the 2, absolute value of x minus 1. These two cancel each other out, and then I'm left with 6. Now I want to get rid of this 2, so I'm going to divide the 2, because the opposite multiplication is division. I'm going to get rid of this. So what's going to happen is now it's going to leave me with x, the absolute value of x minus 1 equals 6 divided by 2, and then I have 3. Now, since my absolute value is all by itself, now I can set up my two versions here. So the first one I have is I have x minus 1 equals our positive 3, and my other version, my x minus 1 equals that negative 3. So basically those are my two answers, or my two solutions that I'm going to solve for next. First step, I want to get my x by itself, so this x, so that means this -1 has to move over. So in order to move it over, I have to change it to the opposite sign. Plus 1, what I do to one side, I do to the other. And the steps are going to be the same in both equations here. So what's going to happen is these two are going to cancel out. Bring down my x. 3 plus 1. There's one solution. And then these two I check. That cancels just like before. X equals -3 plus 1. So since they're opposites again, so we talked about opposite signs, I'm going to subtract. So I'm just going to subtract my values, 3 and 1. Which one's my bigger number? Since 3 is my bigger one, I'm going to leave it as a -2. So that means my two solutions, if they work out, is going to be -2 and 4. Now, we have to check them, because this is what we talk about, the extraneous solution. So sometimes they work, sometimes they don't. So I'm going to take my original equation, 2, absolute value of this 4, minus 1, minus 5, equals 1. So that's what we're going to do. We're going to use our little methods here and just see if it equals 1 at the very end. First step, 2. Absolute value 4 minus 1 is 3. And then minus 5 at the end. So since these two are side by side, I'm going to multiply these two, or do the absolute value first and then multiply them. So what's the absolute value of positive 3? That would just be still a positive 3. And then what happens 2 times that positive 3? 6. And does 6 minus 5 equal 1? And the answer is yes. So that one is going to be one of our solutions. So we know definitely if I come down here, 4 will be a solution. So that's going to be on that number line as a value here. So don't forget, on your number line, make sure we graph it. The other step is, let me change the color just to make it a little bit easier. So 2, absolute value of not 4, this time we have a -2 minus 1 minus 5 equals 1. And so here we go. The first step I have to take care of is, now I have these numbers here. I have 2 absolute values. Since they're both negative, same signs, I'm going to add. It's going to be a -3 minus 5 equals 1. So then from here, what's going to happen is I'm going to take the absolute value -3. Anything in here is going to make it positive, so that's going to still be a positive 3 minus 5. And if you notice, they're going to be the same steps right here. 2 times that positive 3 now. 6 minus 5 equals 1. Is that true? That's our true answer here. So that means this little solution, -2, is going to be a solution on this number line for our equations. And so I have two solutions, one at -2 and 4, because again, they both work in these two examples here.